Hello everybody, welcome back to software engineering. In module 4, we are going to look at software requirements. Upon completion of this course, you'll be able to use various techniques to elicit requirements. Then, to analyze the elicited user requirements in order to derive system requirements. And finally, to document the requirements correctly. Eliciting requirements is probably something that you may be doing in your career, whether the requirement is to develop a software or not. Maybe the requirement is to come up with a new process or a new product or a new service in your organization. What is software requirement? The definition is a condition, good or bad, slow or fast, reliable or unreliable, or capabilities. What does it do? For booking airline tickets, for buying online products, capabilities possessed by a system, the system's components, products, or services to satisfy a contract, agreement, standard, specification, or other formally imposed documents. Software requirements determine whether the completed software is actually good or not. Now, there are three kinds of requirements. Every time when you think about requirements, please think of these three kinds. Number one, the function. What does the software do? Functional requirements. Number two, the quality or non-functional requirements. The quality of software in terms of usable, secured, can be easily maintained. The software is reliable, yeah, it won't hang and it's always running, and it is performing fast, not slow, no delay. These are some of the non-functional or quality requirements. So remember, every time we say non-functional, it means quality. Every time we say functional, it means what the software does for the user. And the other kind that people always forget to mention is constraints. Constraints limit what we can do using the software. For example, this software can only run maximum 3G cellular network, maximum 3G. Yeah. Minimum 3G cellular network, which means that anything below 3G, the software's quality is no longer assured. The other constraints may be language, such as the need to have bilingual, both in English and Bahasa Melayu, yeah, in the system's design. So that is another type of constraint. It's not quality, it's not what the software does, but it's a requirement. It's a requirement that constrains how the design will turn out to be like. So it is good for us to know the differences between the three kinds of requirements. Yeah, but remember, functional requirement is what the system does. Non-functional is about the quality, and constraints refer to restriction or limitation. There are some examples of constraints, such as the system that we build must work with existing infrastructure of the company. There shall be no new technologies introduced. That is a constraint. Yeah. Is it quality? No. Is it what the system does? No. It's a constraint. And then another example, 5B, constraint 2. You notice that the prefix C1, C2 in documentation, we often use C1, C2, C3, so on and so forth, whereby after C there is a digit to show that the statement, the requirement is a constraint type. Now it's a constraint kind. So the second example, the system will only use the data contained in existing university database. So for this system development, no new database to be introduced. Must use existing one. 5C, constraint 3. The system shall be available 99.99% of the time for any 24-hour period. Now, this one is interesting because it does look like quality. It is true that sometimes a constraint can be quite close, can be quite similar to non-functional requirement or quality. Yeah, because the quality will be the constraint for the workability of the system. In situation where you have doubt, then it's always good to specify the requirement as a non-functional requirement rather than constraint. And then 5D, constraint 4, all the university courses shall have summative assessments. As you can see, this is a requirement from the business operation. So it is a constraint. To write a constraint is simple. Just use a common English. There is some specific format introduced by standard bodies such as Object Constraint Language (OCL). But we're not going to visit that in this lecture. So what do we do the first thing? First, we have to get the requirements. We have to gather the requirements. So getting the requirements requires asking. Yeah. Another word for asking would be elicitation. First of all, you need to know whom do you want to elicit. This definitely can be done top-down. Start with the stakeholders, the project sponsors who give you the direction, the goal, the vision. Then you can move down the pyramid of the organization to the managers, to the operational staff, to get all the requirements. At each level, yeah, you will get different kinds of requirement and different amount of details. At higher level, you get the big overview, the strategic view of the system. At lower level, you get more details of how the process ought to be like. Stakeholders, therefore, include managers, experts, engineers, customers, employees, even authorities such as trade unions. Anybody, any group of people who may later influence the outcome of the software development. These people are known as stakeholders. Now, these people will give you business requirements, user requirements, expectations, and the constraints. Business requirements may come from higher level people. User requirements may come from the people who are using the software eventually. Yeah, this will be the operational staff. Expectations and constraints will come from any level of users. Elicitation is not just asking, but also involves analysis of the requirements in order to refine it. Refinement means we go through the list of requirements that we have gathered. In the beginning, the list is quite haphazard, so we need to know which one is important, which one is a repeat of another, which one are contradictory. Now, contradiction may happen between the management and the operation, because management is looking for changes, operation would look for the better way of getting the job done. So, this may involve conflict, and thus, as the business analyst or system analyst, apart of doing elicitation, you also have to negotiate this with them. Then only you can refine the list of requirement to a shorter list. So refinement involves analysis. But before we go into analysis, let's look at elicitation techniques. How do you ask? Now, there are many ways to ask. Yeah, obviously, the easiest is just by talking to the stakeholders. But then, talking to a stakeholder can be done in a more systematic way, or more informally. You can conduct interview in a formal setting, or it can be a casual talk in order for you to get the informational requirements. When the number of stakeholders is huge, for example, getting information from the operational staff, there can be many users. There can be the quantity is huge. Then interview is probably not that viable. Yes, we may interview a few, but in order to get feedbacks from more people, you may want to think about questionnaires. There are pros and cons. Yeah, interview, you can have open interview, and you may get information that you never think of. Questionnaires requires you to do some homework, to think of useful question so that you get useful answers. And the number of questions cannot be too many, and you may not get unexpected information or new information, because when you ask people to write down, yeah, people tend not to reveal too much. A part of asking, other elicitation techniques involve more creative approach, such as brainstorming paradox. This was interesting. What is the difference between brainstorming and brainstorming paradox? Please do find that out. Yeah, please do find that out. I think brainstorming is quite common. Brainstorming is not a typical discussion. Yeah, brainstorming allows the people in the brainstorming group to air out, what their idea, what their thoughts are, and we don't judge, so that we can have a free flow of ideas. Once the ideas are listed, then only the system analysts analyze the ideas, prioritize, refine. Now, brainstorming paradox is exactly like brainstorming, but it is finding what could fail the software. Okay, please revise more on that. Yeah, the meaning of brainstorming paradox. The other creative approach will be change of perspective, six thinking hats. This one usually involves workshop whereby you get representatives from different departments, and you require them to think from different angles. So they are using the six thinking hats analogy. I think you can Google that out, what the six thinking hats are. And then the use of analogy. When you get feedbacks from people, get information from people, sometimes it's not a good idea to ask very direct questions. You know, like in psychological tests, they often use paradox or analogy, something else, that resembles the what they actually want to find out, so that the person who attends the analogy will be more frank in answering. And then other approaches are such as observation, whereby you don't need to say it out, you just be there and observe how things are done. Sometimes observation is a good way of getting a lot of information that you cannot get from listening. Or maybe you can use observation to confirm what you have discovered through survey or creativity techniques. And another important source of requirement will be, surprise, surprise, old documents. Okay, you can look up previous manuals or design documents of the existing system. Yeah, system archaeology means you investigate the existing system for manuals and other kinds of information that you can dig out. Requirement reuse means you specifically find back the software requirement specification and software design description in order to identify the previous requirements. Maybe some of them can be reused. And perspective-based reading is basically similar to literature review. You are just looking for certain information. Instead of reading everything, you're just looking for specific information by browsing through quickly, going through the table of contents, going through the glossary in order to find specific information. And all this can be supported by recording, audio recording or video recording with permission, of course. You can do this in workshops whereby people feel more relaxed, more cooperative because they are not burdened by their daily routines. You can have use case modeling. Use case modeling. Please pay attention to use case modeling. It's one of the more contemporary approach in software engineering. Use case modeling. We are going to cover this in software design. Mind mapping. I think you know what mind mapping is. You draw clouds of ideas and you draw lines connecting clouds. Yeah. Instead of saying out, you draw it out on a whiteboard and get everybody involved. Prototyping is another very popular approach. It may be a bit costly because you need to engage vendor or somebody in your company to come out with a sample software that eventually you're not going to use, but you just build it for the sake of trying out to see how it may be like. That software is not complete. A lot of functions are not working, are not there, are not expected to be there. We're just building for just testing out. You know, like you want to buy a car, you go to the showroom to sample the car first, to try out to do test drive, because you want to sample how it feels like when using that car. It's not your car, it's just a test drive car. Likewise for software. But software is not like buying a car, whereby you buy the car and you can use it as it is. Software usually has to be customized for your organization because every organization has specific processes. So we can't really just buy buy a completed software and just use. Of course, there are some such software, like for example, Word editor, spreadsheet, Excel, no issue. There are some software which are readily used, and you don't need a prototype. You just try the actual software, you like it, buy it. But for systems which you need to customize, no way. You have to you cannot find similar software, or if you can find, it won't be exactly fitting into your business or your operation. So you have to customize it, right? And customization is not so simple. Usually involves quite heavy amount of cost. So you want to do prototyping first to understand why they really need it and to identify the issues that may prop up during the development. And the last but not the least technique in this slide is CRC cards. This one is more technical. CRC cards, in CRC cards, we have facilitators in the workshop, and the facilitator will be holding a stack of cards, size of postcard or smaller. In that card, there are sections in the empty card. whereby everybody will be given an empty card and they are required to determine class, responsibility to the class, and collaborators to the class. Well, I don't intend to go into the technical part of CRC cards. You can Google it out. You can ask me after the lecture because it's really quite technical. If you're interested, you can just talk to me in person. So, requirement elicitation sounds easy, but it's very hard to master. Why? A good requirement elicitation actually captures a very clear requirement so that the actual developed software later on, maybe a few weeks down the road, a few months down the road, a few years down the road, when the software comes out, it is exactly like what the customer or client wants. Well, that is too ideal. Usually it's not like that. Usually it's not like that because if you have heard of the Chinese whisper, CHINESE, Chinese whisper, WHISPR, whisper, it's like a game whereby somebody passes a message from one end to another, yeah, by whispering, and you ask the last person to say out what the first person could have said, and you notice that usually it will be different, even the opposite. The same thing could happen in requirement elicitation. People, the developer may misunderstand, the designer may misunderstand. So, you know, the outcome may be totally different from what the client has actually wanted. Therefore, requirements has to be engineered, has to be done according to certain systematic way to reduce such possibility. Yeah, of course we can do requirements without following specific techniques, fine, but the risk of non-compliance is much higher in those cases. So there is a video by Ian Somerville, one of the textbooks I refer for this lecture, and he's one of the well-known author in software engineering. This video talks about the significance of requirement engineering and how to do it. He explains the steps needed in order to perform requirement elicitation engineered approach. So please do revise. During the revision, please do look at the video by Ian Somerville. The screen here shows you some of the snapshots from that video. Yeah. As you can see, the one next to the portrait of Mr. Somerville or Dr. Somerville, we begin by doing system requirements engineering. The output becomes input for architectural design. And note that the output of requirements is also used for validation, the extreme right. You see, it's not just used for development, but it's also used for validating the final product. That is how important requirement is. Yeah, as you go down the slope, system requirements engineering becomes input for architectural design, becomes input for requirements partitioning, becomes input for requirements engineering, becomes input for development, integration, and finally validation. Requirements also help us to decide whether we need to purchase that component or the system, or we have to develop it from ground up. And some of the important factors to be considered in requirement engineering will be existing system. Of course, the new system must be better than the existing system. What the stakeholders wants. Does the organization has certain standards for the ICT or infrastructure? For example, cybersecurity standards. In PETRONAS, we do have that. Are there any regulations by the government, maybe in terms of taxation for some finance-related processes, and also domain information? Domain refers to the field. Let's say we are building software for hospital. Basically, the domain is healthcare. If you're developing software for the finance department, then the domain will be accounting and finance, corporate finance maybe. If you're developing software for marketing, for selling tickets, for example, obviously the domain is marketing. So all this ends up, all this results in a great requirements, specification of the system, and models of the software. What are the objectives of requirement engineering? The objectives is to know the relevant requirements, not just any requirement. Yeah, relevant requirements where everybody agree, all the stakeholders agree, and these documents and this requirement can be documented clearly according to the standard, and can be managed systematically. And we need to identify which of these requirements is compulsory and which are good to have. Needs, number two, needs means it's compulsory, and such requirements cannot be failed, because failure of such requirement fail the overall project. But those requirements which are identified or labeled as wishes, good to have, we can negotiate out those requirements, or those requirements can be omitted due to constraints of budget and time, maybe. And of course, requirement engineering, as I mentioned just now, if we do it engineer approach, the risk of failure, the risk of capturing the wrong requirements will be much lessened. And this slide is showing you the steps needed to do requirement. What are the steps? Yeah, first ask. Second, analyze. You determine that there are some conflicts. You negotiate the conflicts. You prioritize them. Then you document the requirements so that it can be referred to by other parties involved in the development. You can also refer back to it, because requirements down the road after a few months may be changed, and you can always refer back what has been agreed earlier. And in fact, what has been documented can sometimes become the legal basis in the form of contract awarded to developer to build a software. And because requirements determine success of the software, it is used for validation. So the final software is compared, the completed software is compared against the requirements to determine completeness. So we determine whether it does the function through function requirements, whether the quality is up to expectation through quality or non-functional requirements, and whether the software is completely satisfying the expectation through constraints that have been set in user requirements or system requirements. Okay, since I have mentioned user requirements and system requirements, what do you think could be the difference between the two, user requirements and system requirements? Are they both the same? The answer is no, they are not the same. User requirement means requirements as given by the user. Now, you are a system analyst, you are the expert, you are not a typist, you are not a clerk who just follow instruction and record the document, record the requirements. You are a professional. So you analyze, you prioritize, you provide consultancy to them, right? You provide consultancy to them, telling them, sir, madam, I believe this is the requirement that you actually need, because these few requirements have to be ruled out and better be replaced by this requirement. It captures both and it's better, blah, 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 blah. That is you giving consultancy to the stakeholders. And that list of requirements that you give to them is called system requirements. Coming from them, user requirements. After analysis, you propose to them system requirements. Now, how do we come up with system requirements from user requirements? Analyze. Is it so easy? Depends how complex the requirement is. So you may revise 1 time, 2 times, 3 times. And during the revision, you're not just sitting there and make modification. No. You need to talk to people to validate. Sometimes not clear, or there's a conflict. You negotiate. or you convince them, or you need to get more information. So you see, it's an iteration. It's repeating the process. Elicit, document, validate, negotiate. Elicit again, document, validate, negotiate. Do this a few times until you're satisfied that the user requirement has finally become a system requirement. Clear, which is very clear. And if you look at the point number 2, we have part of user requirement. We have business requirement, right? BUS, business requirement, user requirement, system requirement. BUS. Business requirement means what does the organizational process need to achieve? Business requirement. User requirement comes from the user. Yeah, people who are going to use the software. People. This idea, like I said just in the pyramid, at the operational level, user requirements usually come from them. Business requirement comes from the management or the higher level, strategic level directors. They are also stakeholders. And requirement specification is documentation. After you have BUS, right? You analyze B, you collect the user requirement, and then you analyze, you provide consultancy, you provide system requirement. You have system requirement documented inside a document that is called requirement specification. So ladies and gentlemen, remember, we want to get business requirement, user requirement, analyze, get system requirement, document inside requirement specification. Now, just now I mentioned that as a system analyst, you're not just collecting requirements. You have to analyze. And you provide consultancy. Let me give you one story to illustrate the importance of analysis. Yeah, analysis that is correct may change the result. Now, let us look at one story called survivorship bias. Now, during the World War II, we know that there are two sides involved in the clash, the Allied forces versus the Axis forces. The Allied forces mostly, the members of Allied forces are mostly Americans, the British, the French. Okay, let's look at the Western side, yeah? And then on the other side, Axis forces, mainly the Germans. There were Italians and the Turks, yeah, but mainly the Germans. So aeroplanes were first mostly used in fights, dogfights during World War II. So of course, this is costly. Aeroplanes are costly, but they are needed in their war operations. So aeroplanes that are shot down, you know, the other side. The side with more aeroplanes may eventually win the war. Yeah, the sides with more aeroplanes may eventually win the war. So it is important to make sure that aeroplanes can survive in dogfights. And how do they do that? They analyze. Yeah. So what they do is they interview the pilots. They look at the body of aeroplanes that have been shot. So those airplanes, they come back, right, at a hangar. So they send experts to study the body of the aeroplane. They look at where the bullets hit, and they decide how to make the plane stronger by adding armor. Now, but the funny thing is, after they have done the analysis, after they have strengthened the aeroplane with armor, more planes are shot down. The result seems to be opposite of what they desire. Why? Why do you think so? Why does this happen? How come? How come the result is worse after you analyze this? They study the aeroplane that comes back from war zone. They find out where the aeroplanes get hit, and then by bullets, and then they put armors, more armors on the plane, and supposedly this is going to make the plane stronger and survive the dogfight. But more planes were shot down after that. Why? Because they do the analysis wrongly. The method used is wrong. This is noticed by a mathematician by the name of Abraham Watts. Abraham Watts observed how they do the analysis, and they say, you all are doing the analysis, your analysis method are wrong. You shouldn't investigate aeroplanes that have survived. You should go find the wreckage, aeroplanes that have been shot down. Yes, they are maybe in enemy terrain, but you need to find the wreckage and find where the airplanes get shot. Because those aeroplanes that come back, even though they get shot, there's no point to put armor at those places because those aeroplanes come back. You should find out those aeroplanes that were down by the enemy, and you should put armor in those places instead. Now you're making the aeroplanes heavier, and these airplanes won't survive because they're heavier, and then the armor also doesn't do anything. Because in the first place, these airplanes can come back with those holes. You should add more armor in the places where the enemy successfully brought down the plane. You see the point? Analysis has to be done correctly using the right method. Same goes for elicitation of requirements. Requirement gathering is easy but hard to master. Why do we need to analyze? Because honestly, stakeholders have very vague idea what they actually want, and they may just be expressing the idea in terms of their own personal experience, but it's not the overall organizational need. Yeah, maybe just individual likes or dislikes. And often when you look at the requirements, there'll be a lot of contradiction. And there are also other factors, a part of individual factors such as organizational culture, political factors. Yeah, and another thing that we must not forget is requirements change. Change is constant. That's what people say. Yeah, so requirement that makes sense on day one may unfortunately change at 180 degrees, sometimes halfway or towards the end of the project. Therefore, analysis allow us to identify these risks and come up with strategies to change proof the software. All right. Environment changes. Last time we don't have GST, then we have GST, then GST replaced by SST, and then things keep changing. As I mentioned just now, system requirement is not the same as user requirement. System requirement comes from user requirement. What is the difference between system and user requirements? Which one comes first? Which one comes after analysis? Which one do we actually document? Please answer this on your own. Okay? I move on to the documentation. So after you have analyzed, it's time to put all the requirements into your book of spell. Just kidding. You're putting them into your requirement specifications, the document. Now, to write this document down, we can use typical English, Malay, or suitable language that the developer, the customers can understand. But it doesn't matter what language. But most importantly, it must be clear. But as you can see, even if we want to express a simple idea, after this you want to head somewhere for a meal, maybe for dinner, or maybe you want to eat at home, or you want to just go somewhere. Maybe two of you want to go to the same place. Now, both of you won't describe the intention the same way. Even yourself, you explain to the person one time, you explain to another person another time the same content, you may express differently. This is ambiguous. This introduces ambiguity, which is bad. We want it to be clear. So in order to make it clear, it is good to follow specific format when writing requirements. And this format is called structured natural language. Structured natural language. So basically, there's nothing great about it. Natural language means human spoken English, not computer code, not computer algorithm, not mathematical science, just natural language, the way we speak it on daily basis. But it should be structured. There should be a format. That's why it's called structured natural language. Now I'm talking in natural language. Everybody, you're talking to your wife, your kids in natural language. Yeah, you're talking to your friends in natural language. But when we want to write a requirement, we must write in structured natural language in the documentation so that it becomes clearer. Yeah. So what do you document? You document the requirements, functional requirements, non-functional requirements, and constraints. So what is the format? There are two. There is the same format for both user requirement and system requirement. Yeah, there's the same SNL formats. Now, try to have as short as possible, a sentence that is as short as possible to reduce ambiguity. Find the most suitable word to describe. Let's look at example. When there are unused computer memory, a user shall increase the memory capacity of a virtual machine. Now, this is SNL, structured natural language. Because why? You see, look at the red text. This is the condition. Yeah, this is the condition. And then the blue color one, user, who is affected by the requirement. And then the bold text is either shall or should. Shall means compulsory. It's a compulsory requirement. Should means it is good to have. Remember just now we need to identify whether a requirement is a wish or a need. Need means it's compulsory. Wish means it's good to have. And then finally, the green color one is the capability that the system should have. In this case, increase the memory capacity of a virtual machine. All right. Let's look at another example. When allocated memory is insufficient, okay, condition. When this happen only, the system, the component, the user, okay, shall or should automatically increase the size of memory. The green color one, yeah, is the capability. So that's all about it for SNL. So once you have the requirements documented, right? Don't just be happy. Please validate by going back to the people that you have interviewed, you have elicited to confirm. And sometimes they may disagree, or sometimes you don't agree with their requirements. You need to negotiate out because you have a better picture. You have elicited many people. Yes, they have been doing that job for many years, but you have been interviewing more people. You have information from top down and bottom up. So at this stage, after you have interviewed many people, you are in a position to negotiate back. Maybe there's budget constraint. Maybe there's a time constraint that does not allow that requirement to be done, or maybe it's not technically possible. So how do you validate? To validate, you can review by having a review session, yeah, have meetings, or you can build a prototype based on the requirements and show the prototype. Is this what you want? This is very good, but it's costly and it's time consuming. Or you come up with test cases whereby you come up with scenario. If the system is once the system is built, if the user does this thing, this is the outcome. If the user does that thing, that is the outcome. So you come up with a list of possible scenario that people can imagine how the interaction with the software will be like. Yeah, that is called test cases. They are actually documents on the scenario of using the new system, so that you can, once the system is ready, is built, you can use that test cases to test. You see, test cases is done during the requirement before the system is even built yet. So it requires you to imagine the outcome. And this scenario, you can actually present and discuss their viability. Okay, the final slide will be on summary. Requirement is documentation of user and system conditions and capabilities. Condition, non-function requirement. Capability, function requirement. And of course, don't forget the constraint. Yeah, to achieve an objective of the system. Number 2, system requirements are more detailed and technical than user requirement. Remember, we get user requirements from stakeholders. We analyze, we get the system requirements. System requirements is more detailed, more technical, because system requirements will be used in the system specification, be used by the designer to come up with a software design. Number 3, system requirements include function requirements, non-function requirements, and constraints. See, we start talking about system requirements. We're not talking about user requirements anymore. And system requirements, there are 3 types: function, quality, constraint. Number 4, we don't simply do requirement elicitation just by asking. We must have certain techniques, certain process. That's called requirement engineering, standard way of doing it. It reduces risk of failure. Yeah, elicitation gets requirements from stakeholders, and after analysis, you turn the user requirements into system requirements, and you have them documented in a document called requirement specification, and the requirement should be written in a very clear, unambiguous way called structured natural language. Don't just use normal English, normal Malay or normal Chinese, Indian, which is called natural language. Don't just use normal natural language. Use structured. There's a format. What is the condition? Who or which component? What is it compulsory? Compulsory, you use the word shall. Not compulsory, then use the word should, and then the capability desired. This way you can make the requirement clear. So I also refer to these books in coming out with this slide. You may refer to them in order to learn more. So thank you very much for having me, and I'll see you again in the next lecture.